Hey guys, so in this video I'm going to show you how to create a network of two virtual machines with a load balancer on top of it, so that if one of the virtual machines goes down, the load balancer will route the traffic to the other one. So we're going to do this in Microsoft Azure, and there are multiple ways of doing this. The first and obvious one is through the Azure portal. Also, you can do it through the Azure CLI, which is a command line tool. And finally, you can do it through ARM template, ARM template, which is basically a JSON file that contains all the settings, and you feed it to Azure and it will create everything for you in a few minutes. So this is basically very easy to do. It's gonna take, and we're gonna use Azure CLI, and I'm gonna show you. It's gonna take only a few minutes, maybe 5 minutes, but where before it used to take days to do this when you had to actually work with actual physical servers. Anyway, let's get started. So first, I'm gonna open Azure portal. I have it here. To open the Azure CLI, I'm going to use this one here. There's a button called Cloud Shell. I had it open. I'm going to reconnect here. I think the first time you click on this, it's going to request that you create a storage account, which is fine. Just click yes, and it will create an account. You can also, there's a Azure CLI you can download on your desktop, so you can use it. But here it's very easy because it's convenient. We have the Azure portal open, and we can use the portal to verify that everything is being created. So the first thing we need to do is create a resource group here, because everything is contained inside the resource group, and the resource group allows you to control everything. Basically, if you want to delete the whole thing, you just delete the resource group and everything will be deleted. So to create the resource group, we're gonna type in AZ group create -- name, and then here select the name of the resource group, demo-lb, and the location. I'm choosing West Europe, but you can use any other location available in Azure. You hit enter, and if I refresh my resource groups here, see, you have now demo-lb. So the resource group is created. The next step is I need to create a public IP, so that we can access those virtual machines from the internet. And to do that, I'm gonna paste AZ network public IP create -- resource group demo-lb. That's the name of the resource group we created earlier. -- name, the name of the public IP, which is anything you want to name it, and then SKU is the standard IP. Once I hit enter, usually it takes few seconds to create an IP, and here we go. We should be able to see the IP address, which is 51.105.211.122. So what's the next step? Once we create the public IP, now we need to create a load balancer, and there are few things involved with the load balancer. So the first step is creating the actual load balancer, and I will show you the command here. AZ network LB stands for load balancer create, and then you specify the resource group which we want to create inside, which is the one that I created earlier, demo-lb, and then you want to give it a name for the load balancer, and then which IP you want to associate it with. So public IP address, I give it the same name that I gave my public IP earlier. And then for the load balancer, you need to specify a front-end pool and a back-end pool. So you just give it a name, and then you're gonna connect stuff to it. So front-end IP name, and then back-end pool name, and then SKU standard. So this will create the load balancer. So the load balancer is created. Let me verify it is done. So in the resource group, once you click on it, you see we have the public IP and then we have the load balancer. So in the picture here, we see the load balancer has these things, HP, which stands for health probe. Health probe is basically the way it works. When you connect virtual machines to the load balancer, you need to have a way to tell the load balancer that the virtual machine is healthy. And the way it works is that if the load balancer will frequently check if the virtual machine is healthy. If it's not healthy, it's going to take it from out of the circulations. So in our case, we're going to use like an HTTP endpoint, like an endpoint where the load balancer can call and see if the virtual machine will respond. So let's input that command in the Azure CLI. Paste. So it's AZ network load balancer probe create, and then you specify the resource group name, the load balancer name, and the name of the health probe. I just gave it health probe, and then the protocol HTTP in our case, the port is 80, and then the path, which is health.html. So we need to remember this. We need, when we create our virtual machines, we need to create those endpoints health.html, and then the interval is every 10 seconds. It's going to check the health and probe endpoint, and then threshold, which is if it fails 3 times, then it's going to take it out of the circulations, which is, I guess, 30 seconds. We can, of course, change this. Okay, so once that's created, now we need to create those two rules. Basically, we have to create a rule that says if there's a traffic coming from port 80, just forward it to the port 80, and if traffic is coming to port 5000, forward it to port 22. Those are rules you can assign on your load balancer, basically like a firewall, similar to a firewall works. So to do that, I'm gonna paste this command. So it's similar, AZ network LB rule. Now you're specifying rule and then create. You're creating a new rule. You specify the resource group, you specify the load balancer name, and then the name for the rule, and the protocol is TCP front-end port 80, back-end port 80. So port 80 transfer to 80, and then front-end IP name, and the backend pool name, which we have when we created the load balancer, and then the probe name, which is basically you need to specify this so it doesn't forward it to a unhealthy virtual machine. Well, I had an issue. I had missed a dash in the health probe. It should be dash dash probe name. So let's try again. Okay, let's do the next rule, which is port 5001 to port 22. I think in the picture I put 5000. Okay, let's change it to 5000. Let's keep it 5000. Oh, that's fine. Let's give it a name. Natural. So the next step, once we're done with the load balancer, is create a virtual network with a sub network inside it. So to do that, I'm gonna paste this command. vnet create inside the resource group with the name, and then address prefix is, this is a private IP with 16, and then for the subnet is .1.0 with 24, with the mask of 24. The next thing we need to do is create the NSG, which is basically like a firewall for the subnetwork. And in this case, we're just gonna create two rules that allows port 80 and 22 to come in. So we paste in this command, AZ network NSG create resource group, and then the name. For the first rule, it's AZ network NSG rule create resource group, NSG name, and then allow HTTP. You give it a priority, and then protocol is TCP, destination port is 80. So this will allow all traffic on port 80, TCP port 80, to go through. The next rule is for port 22, the same thing. And finally, we need a command, so we update our subnetwork and associate it with this new NSG. So we're basically saying update my subnetwork and give it, assign the network security group web NSG to it. So once that's done, we're basically done. Here we need to create the network interfaces, which are necessary to connect the virtual machines to our load balancer. So we're going to create two network interfaces. So here I have AZ network, create a network interface, specify resource group, and then give it a name, specify the virtual network, specify the subnetwork, the load balancer name, and then here is where you connect the network interface to the backend pool of the load balancer. And this is the name you gave when you created the load balancer. And then you want to specify, I think we gave this net rule, the name, to associate that whenever there's a traffic on port 5000, and it's going to come to this network interface. Let's create the other network interface. So basically we created those two. Now we have to create two virtual machines and assign them to those network interfaces. And as we're doing, we can refresh to see everything is getting created. Let's create this one. This is create a virtual machine with a name, with an image. When you create a virtual machine, you have to specify an image, which we're using Ubuntu, and then you specify the size, which basically specifies the size of the CPU, how much memory, etc. And then username, and then SSH key, we want to generate it, and then the zone stands for availability, which we won't discuss now, it's an advanced topic for later on, and then we specify the network interface. The first virtual machine is created, and then let's do the same for the second one. Okay, that's done. So now we have everything created. Everything should be functional. So how do we test this? So what I'm going to do is now log into each of the virtual machines using SSH, and then install a web server on them. Since they are like empty Linux servers, I'm going to install an nginx web server, and then add like a simple website that where it says this is VM1 with the health probe, of course, and then this is VM2 with also the health probe. And then what we can do is access the public IP, and we will be, depending on the load balancer, we should see either VM1 or VM2. And then I'm going to take one of the virtual machines, I'm going to stop it, basically shut it down, and then we should refresh the page, and we should see that the load balancer will automatically route the traffic to the other virtual machine. So let's try it. So to do that, we have to use SSH, and you need to run this command, SSH agent, and then you need to know the IP address. So let's see here. If you click on the public IP, that's your public IP. I'm gonna copy it, and then what I'm gonna do is I'm gonna type in SSH-A, and then Azure Mall, which is the virtual network name we created, and then paste in the IP, and then -P, which is the port. I think in our load balancer we only allowed port 80 and 5001. So for when you access port 5001, it's going to redirect it to the first virtual machine, to the port 22. So we should be able to log in. Yes. So we are on virtual machine 1. So what I'm gonna do is install nginx, which is sudo apt-get install nginx. So now since the web server is installed, I'm gonna bring in the files for the website. I'm gonna use a Git repository to do that. So I do git clone, and this is the repository for it. It's basically just a basic HTML file that says, hey, this is virtual machine. To do that, so I'm gonna copy the HTML files to the root folder of the web server. So now web virtual machine 1 is done. So now we need to connect to web virtual machine 2, and in order to do that, we're gonna use SSH again, but we're gonna connect from web virtual machine 1 to web virtual machine 2, since port 22 is only open through the load balancer by accessing web virtual machine 1. So I need the IP address of the virtual machine 2, which is the internal IP address, which is, if I click on this one, it's 10.0.1.5. and yes, you can access web virtual machine 2. And now I'm gonna do the same thing, install nginx, and then get the repository, and then copy it to the root folder of the server. And then so now we need to exit from webvm2, exit. Now we're back to webvm1. I'm going to exit from webvm1, and now back to the root of the AZ CLI. So now everything is done. So what we need to do to test it, get the public IP, copy the public IP and put it in my browser, and let's see. We are on VM2. If I refresh it, it's gonna give the same VM, because the load balancer actually by default uses session affinity, which is basically if you initially connect to the virtual machine 2, it's gonna keep sending you to the same virtual machine. But let's try something. Since this is trying to go into VM1, let's try to stop VM2. If we kill VM2, how? Let me refresh this. So VM2 is this guy. I'm gonna stop it. Do you want to stop VM2? Yes. It's stopping it. Let's try refresh. Immediately now we're going to VM1. The load balancer is routing the traffic to the other virtual machine. Last thing I want to show you is the ARM template. If you want to go to the resource group and go to the export template, it's gonna give you a template of a JSON file that contains all the settings of your infrastructure, and you can use this template to basically recreate the whole thing. You can delete the whole resource group, and then using this template you can click it, you can use it to regenerate the whole thing. It's taking a while to generate the template. And here we go. This is basically has all the components that you created, like the load balancer, the IP, the virtual machines, the NSG, the virtual network, and then it has all the parameters. You can actually have a variables where you can change the names of the instead of web VM, you can specify different names, and this is good for production if you want to have like a infrastructure as a code. So that's it. Thank you for watching.